Okay, so this is going to be our screencastify video for section 1 for parametric equations. So we're going to leave function mode, but just refer you to this. If we look at we start with the unit circle. In the unit circle, x squared plus y squared equals 1. Or you could say cosine squared plus sine squared equals 1. We solve this for y. We would add a negative x squared to both sides. If we take the square root of both sides, you'd have 2 roots. But the circle is not a function, fails the vertical line test. So that's why we have to either graph it in 2 lines in y equals or draw each branch separately. But we can draw the unit circle in parametric mode. And one thing that parametric mode does is it allows you to graph things that aren't functions. So if we put cosine t in x and sine t in y, we would get the unit circle. And we're going to show you that. But before we get to that, we're going to deal with the transformations. So if I were to do a slide following a scale change to the unit circle in function mode, it is in the left column, which we are not going to deal with, other than the first line. So let's look at the first line. This is a slide of h units to the right up k. The open circle is following a scale change of magnitude a, b. So what's been done to x? X has been expanded by a factor of a. So we go to the unit circle that we had at the top, and we divide x by a. We do the opposite. Y has been expanded by a factor of b. We do the opposite to y. We divide it by b. The slide, the translation, follows the scale change. So then we turn around and replace x with x, take away h, which would move it h units to the right. And we replace y with y, take away k, which would move it up k units. And then we got y by itself, we'd end up with this mess down here. But it's much more user-friendly if we just take this instead equal to cosine t. Why? Because we have x equals cosine t. We want to do the transformation. So to expand our x's by a magnitude of a, we divide x by a. And then we do the slide. So replace x with x, take away h. Then to get x by itself, we would undo what's been done to the to x, multiply both sides by a, add h to both sides, and we would get this. Same thing for y. We do the opposite. We expand it by a factor of b, and then we replace y with y, take away k, and we would have this. So example 3 in the book asks you to graph this ellipse. In the ellipse, there's no slide, but the scale change is a magnitude 3 units horizontally and 4 units vertically. So we can type this in our parametric mode equation. And what happened? Well, if we look up here, it really is x divided by 3 that expands the circle 3 units horizontally. But then we have to get x by itself, so we'd undo that by multiplying both sides by 3. We expanded it 4 units up. So when we divide y by 4, we get y by itself by then clearing that fraction and multiplying both sides by 4. And there was no slide. So this would be the image. Now, we could go here, and we're going to deal with the window also. We could go and just put the preset in here. So I have it down here in x3 and y3, which is what's over here on that table above. And I already did the transformation. I have a times cosine t plus h, y equals b sine t plus k, which are these 2 lines up here. And then we could just go second quit. We can store values for a, b, h, and k. So the slide left and right, we didn't. So it would be 0 store alpha h Then we're going to type colon 0 store alpha K and then in the problem, in the example in the book, the magnitude A was 3, so we'll go 3 store alpha A. Whoops, I need to call. Three store alpha A, 4 store alpha B, push enter, and those values are in there. So if I go to window, ready? This window right here is a Zoom 4 window. Now, if you have an older calculator, you have less pixels on the screen. So your X-min and X-max may be negative 4.7 to 4.7. That's fine. And your Y's negative 3.1 to 3.1. Okay, that just is how many pixels you have on the screen. So this calculator is newer, it has better resolution. But this is what's been inserted, these 3 lines up top. The T-min, start at when? Start at 0. We made the T-max 2 pi. Well, it's, we're dealing with a trigonometric shape. We can adjust this. And we made the T-step pi divided by 24. So the T-step is how often the calculator takes a picture of the graph and then it turns around and connects the picture. So if I go here, I'm going to turn it on. I turn on my X3, Y3 now, push graph, you get the picture that's on the PDF. Okay? But instead of on the PDF where we typed it at the top and put those values in, the way we have it now in Y equals, we can just change these values on the home screen. We wouldn't have to type the whole thing. Okay? So we're asking you to go to problem 13. Pause the video. That's your model. You go to problem 13. So for 13, ready? Well, we had a different window. And this is actually, if you look here, this window is the old window, negative 4.7 to 4.7. But they asked you to go from 0 to pi, not 0 to 2 pi. They specified the T-min and T-max. And then what happened? This was interchanged. So it's 4 sine T, 2 cosine T. So our preset wasn't effective that way because in our here, we had the calculator set for this, which is more typical. We had cosine in the X line and sine in the Y line. Okay, so this is atypical the way this problem 13 went, but that would be your picture. Okay. Now, lines and other curves, these are not AP topics, but you'll get a little bit of reinforcement as to how the mode works. Right? So they said, suppose you drew this. X equals 3t and y equals 2 plus a negative 2t from 0 to 1. There's the line segment. Well, I could do that in function mode. Where's that coming from? So the point is, if at x and y you set them both equal to t, then they have to be equal to each other. So I solved this, what I was given in this top line up here for t. So you divide both sides on the top line, the x line, by 3, you get x over 3. For this line, you would add a negative 2 to the y and divide by negative 2. But both of these things are equal to t, so they must be equal to each other. So we just set this equal to that, and we get y by itself. So we would multiply both sides by a negative 2, and then add 2 to both sides. And we would get this linear equation, which has a slope of negative 2/3 and intercept of 2. And what's happening? Well, because we didn't limit that, we're in function mode now. We didn't limit that from 0 to 1. It's just going to trace over that line segment that we got in example 4. So this is your model. Pause the video again and and then try and draw the problem that goes with 17. So for 17, x equal t, Mike would want takeaway t. So we want to set them equal to each other. So x equals y take away 1. Get this t by itself. We would add a -1 to both sides, divide both sides by -1. So here, this x is from here. What this y equals is over here. You y by itself and you get a -x plus 1. Okay. Example 5, we're not going to go forward on that. Example 5, if you want to read what's on here, it's on the PDF and it sends you to problem 23. But linear equations are not in parametric mode, are not AP learning objectives, so we're not going to deal with it. Okay. So we will see you for the next lesson is 1.5, and that's actually a Zoom video.